Hello everyone, good morning. So today we are going to start one new exercise, that is exercise 2C. I have already completed exercise 2A, 2B and the key concepts of whole number. So today we will focus on some properties of whole number, basically over addition. Some properties like what type of properties are there? Closure property, commutative property, associative property, additive identity. Some more concepts are there. So we just understand one by one. So without wasting any time, let's start. So here the four topics that we have to cover first of all before going to exercise 2C. So here properties of whole number over addition. So here the operation is basically addition. So first property is that closure property. What do you mean by closure property? Closure property means what? Here if I take two whole numbers, are there and if I put plus in between these two whole numbers, let's say I have two whole numbers and then I put plus over there, right? Plus in between these two whole numbers. So the answer should be a whole number. If it is not a whole number, then we cannot say closure property will be applicable over addition. So that is the meaning of closure property. Whatever the transformation is going on between these two whole numbers, this two means there is no specific whole numbers that we are talking about. In general, we are talking about any whole number for that matter. If I took two whole numbers from any of the whole numbers, then it must satisfy that the property. What is the property? That when we are adding two whole numbers, then the result must be a whole number. So that is basically your closure property. So this property is something like A plus B is basically whole numbers. The representation of whole number is W, as I have told you earlier. Now here this is where A comma B are whole numbers. A comma B are whole numbers. So the topic is that when we add two whole numbers basically, so it will be a whole number. If it is not a whole number, then we cannot say that the closure property will be applicable over addition. So the next part is that commutative property. Commutative property is nothing but interchanging of two whole numbers, but the result will be same. So what I am talking about, let's say A plus B, it must be equal to B plus A. To make that complex thing more simple, I just take one example for you. Here 3 plus 5, what is the result? 8. So if I take 5 plus 3, what is the result? 8. So here I have taken just two numbers, that is 3 and 5, and what I saw, even if I interchange the numbers and the plus will remain same, the result will be same. It will not change. 3 plus 5 gives you 8 and 5 plus 3 gives you 8, even if the numbers are getting interchanged. So the meaning is that commutative property says that A plus B, it should be equal to B plus A. So here the next property is associative property. I think now the two properties are clear. If you have any doubt, just give me a text. I will just make you much more clear to you. Now the next property is associative property. Associative property means, first of all, we will do this, which will come under bracket. These two numbers we will operate first. Then whatever the result comes, we have to operate with the third number. The three of the numbers are whole number basically. So the first number is, let's say 3, and the next number is, let's say 5, and the third number is, let's say 7, right? So the sign is plus. So first we have to operate 3 plus 5. What is the result? 8. And there plus sign is also there. So 8 plus 7 is what? 15. So that is the first part. And let's just take one more part. First we have to do B plus C because the bracket is over B and C. So first we have to do B plus C. The numbers will be same, but the brackets are different in each of the cases. If the result come if the result will be equal in both the cases, then we can say that associative property will be applicable. Let's just check whether the result will be same or not. So here 3 plus 5 plus 7. Now 5 plus 7 will be 12, right? And 3 is over here, the answer will be 15. So in both the cases, the answer will be same. So we can say that 3, 5, 7 satisfies associative property over addition. So that I have taken just particular numbers, right? For each and every numbers of whole number, for the set of whole numbers, if I took each and every numbers, the result will be same and it will be applicable in each of the following cases. So each of the following cases that I am talking about, commutative property, associative property and closure property, for each and every numbers of whole numbers, it will satisfy these three properties. Now the last property is additive identity. Additive identity is nothing but if I take 2, so what is the number when we add with 2 so that the result will become 2? The question is, what is that particular number that we can pick so that if I add that number with 2, the result will be 2? That is the question. So what I am talking about, 2 plus what number gives you 2? It is very easy. That is what? That is basically 0. It is basically 0. So if I do the same thing, if I interchange this 2, what is the result? The result will be same. 0 is that number which will be add up to each of the numbers of whole number. For that, the result will be same. The result will be A. So the representation is A plus 0 gives you A and 0 plus A gives you A. So the additive identity of A is basically 0. Additive identity means what? Whatever the number is getting operated with, that or whatever the number it is operated with A, it should not change its own identity. It would not change its own identity. What is that identity? That is actually A. So if I am doing A plus some other number, so the answer will not be A, it will be some other number. But if I took 0 for that matter, then only it is the only case where the answer will be A. So the identity will not be lost. So these are the 4 topics of basically the properties of whole number over addition. First one is closure, then commutative, then associative, and then additive identity. So now I think now these concepts are clear. So clearly we can jump to our main section, that is exercise 2C. So now here is exercise 2C. Let's just jump into question number 1. Fill in the blanks to make each of the following statement a true statement basically. So that the first question is here, some gaps are there and we have to fill it out. So the first question is 2957. 2957 plus 0 will be how much? Will be how much? That is very easy. 2957 only. And we know that because additive identity is over here and I have just discussed with all of you. So now the next question is that exercise 2C, question number 1-4. 59362 plus how much? Plus how much gives you 994 plus 59362. That is basically what? That is basically the property of commutativity. The property of commutativity. Here A plus B, it should be equal to B plus A. So here B and B, the gap is B and B. Here B is this and A is this. Here A is this and it should be B. So here B and B both are same. So I just fill it out, 994. So that is our question number 1. Let's just straight jump into question number 2. Add each of the following and check by reversing the order of addends. So addends means what? The numbers which are getting added. The numbers which are getting added. So here 2 numbers are there. So we have to add this number and simply after adding up, whatever the result come, it will come in this form, and then simply we just reverse the order of these 2 numbers. and simply find it out. Whatever the result will come, those two results will be same or not. That is our task. So let's just add first of all. So here the number is 12940, and how many nines are there? 4 nines. So 9999. So just add these two numbers. 0 plus 9 is 9, 4 plus 9 is 13, 1 carry, 9 plus 9 is 18, plus 1 19, 1 carry, 9 plus 1 is 10, 10 plus 2 is 12, 1 carry and 2. So the answer is 22,939. So the answer is basically 22,939, implies it is basically 12940 plus 9999. So if I reverse this number, 9999 plus 12940, what is the result? Simply 9999 and 12940, that we have to do. So 9 plus 0 is 9, 9 plus 4 is 13, 1 carry, 9 plus 1 is 10, 10 plus 9 is 19, 1 carry, 10, 9 plus 1 is 10, 10 plus 2 is 12 and 1 carry 2. So in that case also the number will be absolutely same. So basically it is saying that this question is basically asking you whether you know the law of commutativity over addition. So we definitely know that, because the two numbers, if they rearrange, if I rearrange these two numbers also, if I interchange their position, the answer will be same. And we know that because if I take thousands of numbers, if I take the 1000 group pairs of numbers and check whether the commutativity will be applicable or not in particularly in whole number, then we'll see that all the numbers are equal. So here is question number 3. Question number 3 is saying basically determine each of the following sums using suitable rearrangement. So they are actually linking you. So here is question number 3. Question number 3 is basically determine each of the following sums using suitable rearrangement. So what they want to say that we have to find out two pairs of numbers basically, where we can make some zeros. What I'm talking about, if I just forget these questions first of all, let me just take one example. Let's say 3, 7, 5, 5. So there are multiple ways of doing this. Basically, if I put instead of comma, if I put plus, there are multiple ways of doing that thing. First of all, we can rearrange like this way, 3 plus 5, so that is basically 8, and then 7 plus 5, that is basically 12, and then we can add these two numbers. So what is the result? 20. In that way, it also, the result will be 20, I know that. But they are talking about, in this particular question, they are talking about we have to find out the zero quantity. We have to find out what? Zero quantity. Here 3 and 7, it is making 0, that is basically 10. So here 5 plus 5 is basically 10. Then we can add these two numbers, the answer will be 20. In each of the cases, in both the cases basically, the answer will be 20, that I know. But the question is saying, the question is basically indicating us to find out such pair of numbers where we can easily find out some zero quantities. That the question is trying to say. So let's just come back to our actual question. Here 647 is there, 142 is there, 858 is there, and 253 is there. Now how will I find out? Because here the numbers are too small, so it is easily recognizable, right? But in that case the numbers are 3-digit numbers. Some problem is there, but some of you might know this question, I know that. All right, so here just see, the last digit is 7. In that case the last digit is 7. So what should I add with 7 so that the result will be 10? What should I add with 7 so that the result will be 10? That is basically 3. Now find out such numbers along all the 3 numbers where the last digit will be 3. 283. So the number is this one. So first of all, we have to pair up 647 with 253. Now let's just find out the next number. Here 2 is there, so now the last number is 858. So it is very much understandable that these two are getting paired off of, but the formula is absolutely same for this condition and for that condition as well. So here 2 is there, the last number, the ones place is 2. So to fill up with some numbers, for that the result will be 10. What will be that number? That is basically 2 plus 8 gives you 10. So here at ones place 8 is there. So these two numbers are getting paired up with each other, and these two numbers are getting paired up with each other, so that it will be our suitable rearrangement. So let's just write down the answer quickly. So 647 plus 253, that is our rearrangement, and then plus 142 plus 858, right? So now simply just add these two numbers. You can do like this way, whatever you feel comfortable with, you just do like that one. For me, just looking up the two numbers and doing the sum is very much easy. So here 7 plus 3 is 10, 1 carry, 4 plus 5 is 9, 9 plus 1 is 10, 10, 1 carry, 6 plus 2 is 8, plus 1 is 9. So here the same thing is there, 7 plus 3 is 10, 1 carry, 5 plus 4 is 9, 9 plus 1 is 10, 1 carry, 6 plus 1 is 7, 7 plus 2 is 9. So here the 900 is the answer of this pair. Now let's just find out the answer of this particular pair. Pause the video and do this. So I hope you have found out the answer. What is the answer? What is the answer? Let me just calculate, because I am not getting your response basically. So 2 plus 8 is 10, 1 carry, 5 plus 4 is 9, plus 1 10 carry, 8 plus 1 is 9, 9 plus 1 10. So the answer will be 1900. So that is the answer for question number 3-1. So let's just straight jump into question number 4. What is that question? 496 plus 497 plus 498 plus 499 plus 1 plus 2 plus 3 plus 4. So here the same formula will be applicable to this particular question as well. So first number is 6. Here the ones place is 6. So we have to find out that number 4. Where is number 4? There is number 4. Now see, 7 is there, 3 is there, 8 is there, 2 is there, 9 is there, 1 is there. So we have to pair up all such numbers with their respective ones place. So here the answer will be like that way. First of all, we have to do the rearrangement. 496 plus 4 plus 497 plus 3 plus 498 plus 2 plus 499 plus 1. So that is the suitable rearrangement, and simply we have to find out the answer. The answer for all the pairs will be same, that is basically 500. So 500 plus 500, so how many 500s will be there? 4 500s. And 4 500s, what is the sum of 4 500s? That is basically 2000. So that is the answer for question number 3, 1 and 4. So now we are coming towards the end of this particular session. So let's just jump into question number 4. Find the sum by using a short method. We have to find out the short method for doing this particular sum. So here 19,782 plus 9,999. So that is our question, and we have to find out the shortest method for doing this particular sum. So what is that shortest method basically? So here, now see, 19,782 will remain same, and we can write 9,999 like 10,000 minus 1. 10,000, the previous number of 10,000 is basically 9,999, which is what? Which is the predecessor, of 9,999. So if I simply add these two numbers, what will be the result? The result will be 29,782. 29,782 minus 1 is basically your answer, 29,781. So that is the shortest method to do this particular sum. And the next question is question number 4-2, you have to do in your home. So now question number 5, fill in the blanks. There is the last question of the day. If two whole numbers are added, the sum is always a, I have already told you in closure property, if the pair of whole numbers are getting added up with each other, so the result will be a whole number. So the result will be a whole number. So now whole numbers are dash under addition. Whole numbers are what under addition? That the whole numbers are closed under addition. What do you mean by closed? Closed is basically identifying, closed is basically indicating the closure property. Closure and closed. So whole numbers are closed under addition, because if I take the pairs of numbers under whole number and if I add it up, because under addition is given, if I add it up, the result will be a whole number. So last question is, if P is an alphabet which is representing some whole number, is a whole number such that P plus P gives you P, P plus P gives you P, then the P is equal to what? Now tell me, which number in whole number, the set of whole numbers, can be represented this particular statement? Which number? When we are talking about this type of arrangement, that is basically indicating the additive identity. We know that A plus what gives you A? That is basically 0. So here the question is P plus P. So here the additive identity will be 0, that I know. But here P and P both are there. So that A, it should be 0. It should be 0. For that, 0 plus 0 gives you 0. A plus 0 gives you A. A is a general number that we have to take. Arbitrary number, like it is a general alphabet that we have taken to represent all the whole numbers. If I want to take all the whole numbers, so that is basically a representation of A. So for that particular use, to satisfy this particular statement, we have to take A equal to 0 such that 0 plus 0 gives you 0, so which is actually satisfying this particular arrangement. So here then P must be what? It should be 0. So that is the end of this exercise, that is exercise 2C. Whatever the question remains, you have to do in your home. Stay safe and I'll see you in my next class.